Tame Tux's Time Toil, or how to get your Linux machine to use timers to do our work for us. What timers are available to us? Which ones should we use? And for what purposes? And what else can these tools be used for? Sit back and enjoy the ride as I unveil this timer onion for us, starting at the core and adding one layer at a time. Let's transcend you to a ticking timer tycoon of temporal power. Have you ever been wondering about when you try to log in and wait a bit too long at the login page? The login dialog disappears. Who does that? And how? And secondly, those weekly reminders that there are updates to download and install. Who checks for those and how? So, what timers are available to us? In the beginning, even before Linux ever existed, Unix had cron. We still have cron. It is still part of the Ubuntu 22.4 I am using right now. Another major player in the Ubuntu 22.4 is systemd.timer. It is a relatively new addition to systemd, so it has not been adapted to all distributions yet. But as it's on the rise, let's cover it here. Then we have some CLI timers, at and batched, followed by a group of cron derivatives, anacron, fcron, incron, and dcron. Finally, we have a group of multi-machine tools, and part of this is Apache Airflow and Celery. But when should we use each type of timer? On my Ubuntu laptop, I have cron, systemd.timer and anacron used and installed. Why is that? Cron is used for straight timing tasks with no or few dependencies on other services. Typical tasks includes periodical database updates, regular cleanups of files and folders, automatic report generations, security checks and update checks, reminders, and email fetching. Systemd.timer is used for timing tasks with a bit more complex nature, and that can both be a bit randomized spread in time or a dependency on other things but time itself. And typical tasks include triggering scripts that depends on other system services like Wi-Fi or internet connection, tasks to be run before a suspend or after resume, but also simple periodic tasks. Now, both cron and systemd.timer are used for rotating logs and processing log files, synchronizing files and directories, backups maybe, running monitoring scripts and health checks, executing batch processing jobs for data analysis, machine learning, or other compute tasks, fetching and processing data from APIs or external sources, at regular intervals. Anacron is similar to cron, but it is used on machines that are often shut off, like laptops. That's why it's in my laptop. It ensures that scheduled jobs are run using intervals, even if the system is powered off when the job was initially scheduled to run. My Ubuntu laptop also has some of these timers. Fcron. This job scheduler can replace both cron and anacron. Fcron is designed for systems that are not running all the time, but it can also manage tasks on systems that never shut down. Incron. The incron daemon is similar to cron, but instead of running tasks based on time, it runs commands in response of file system events. It uses the Linux kernel's iNotify interface to watch specified files or directories and execute commands when certain files or directory events occur, such as file creation, modification, or deletion. This also makes it a replacement for part of systemd. Dcron, or DeLong's cron, is a lightweight cron implementation designed to be simple and easy to configure. It is known for being straightforward and easy to secure, because it minimizes the code that needs to be run with root privileges. And finally, yet again we mention the group of timer tools who goes beyond one PC and synchronizes tasks over a cluster of machines, like Apache Airflow and Celery. These are often used in data processing and analytics environments, probably also used in AI. So, if I need a periodic tasks, how do I set it up? We will look at two examples, as those workflows will cover the main bulk of all types of timers. First, let's set up a cron timer. With that, you use the command crontab-e. This opens up an editor where you enter one line of text. This text string defines minute, hour, day of month, month, day of week, followed by a command. This command can be either to run a script or to do just a command. In my example, I have a script that puts up a notification in the notification bar. And it does this every minute. And the 5 stars that I use here in this cron script says that it runs this script every minute forever. Secondly, let's do the same thing with systemd. Here we need to create 2 files, one called task.timer and another one called task.service. The timer file defines when it should be triggered, and the service file tells it what to do. I use a similar script like the one in the cron example. The systemd example seems like a bit more work to set up, and it is. but it will be worth it if we start combining the recurring notifications to only appear when we have a working Wi-Fi connection and a specific USB is mounted in the file system. These extra conditions will only result in 2 more lines in the service file. But to do the same, we need a lot of lines of code in the script for a similar solution using cron. So use cron for simple timing tasks and use systemd.timer when you have a complex dependency plus some timers. Then, what else can these tools trigger on? First, we have the CLI command batch. Batch will wait with execution of a command until the system load falls under a specific level. So, system load can be used as a trigger. Then we have fcron, who can trigger on changes in the file system, like creation of a file or directory, finish writing to a file, or mounting a USB drive. Then we have the behemoth called systemd. It can trigger on manuals, boot or resume events, timers, sockets or net traffic, file system changes, kernel devices that might appear or are modified, and dbus messages. And of course, also status of any other systemd service. On top of this, every service that systemd has also has dependency on other services, defined by requires, wants, binds to, after, before, part of, conflicts, or on failure. Now, covering all of systemd is way out of scope for this video, so let me know in the comments below if you would like to hear a rundown of systemd as itself. Let's just say that systemd is the one responsible for booting up a Ubuntu 22.4 system, so it can handle that kind of complexity. Now, are you feeling Tychoonishly powerful yet? If not, I have a few other Linux videos on this channel. The one suggested over here is the one YouTube really thinks you should take a look into next. Click it, and I will see you there in just a second.